Hello everyone, welcome back to my YouTube channel. Today we are going to do more problems on Hurwitz polynomial. Let's consider today's first problem, question number 2, that is P of s is equal to 3s square cube plus 4s plus 1. Okay, and first thing we have written the question, and the first thing that we are going to do after that is check whether all the terms are present. Here it starts with s cube. So which all terms should exist in that questions? Just like s cube, s square, s and s raised to 0. So s cube exists, but there is no s square terms. So it means not all terms are present. All terms are not present. Hence, we could say it is not a Hurwitz polynomial. So now the first question കഴിഞ്ഞു. Then we'll move on to our next question, that is check whether the following polynomials is Hurwitz or not. We'll write the first question, that is P of s is equal to s raised to 5 plus 3s cube plus 2s. We'll solve this. Okay. If we consider this question, we could see that there are only odd terms here. That is s raised to 5, s raised to 4, s raised to 3, s raised to 2, s raised to 1, s raised to 0. There are only s raised to 5, s raised to 3 and s raised to 1. That is odd terms. So what we are going to do is, in this method we won't be, there is nothing to separate like odd terms and even terms. So we will be writing derivative of the given function, that is p dash of s, and we'll get 5s raised to 4 plus, that is ns raised to n minus 1 only. That is s raised to d by ds of s raised to n will d by dt of s raised to n will give you n s raised to n minus 1. Okay, we got 5 s raised to 4. Then next one is 9 s raised to 2 plus 2. Okay. Okay, we got that. Now what we'll be doing is we'll do continued fraction. Continued fraction, just like we did in the first question that we had done, we'll do continued fraction. But this time it is not n by s or m by m by s or m by s or n by s. This is what we did last time. This time we'll be doing p of s by p dash of s, because there is only odd terms in this given question. So I'm gonna write p of s. P of s is s raised to 5 3s cube plus 2s divided by 5s raised to 4 plus 9s square plus 2. Okay, now we are gonna do continued fraction. That will be, we'll put s raised to 5, the bigger one, the numerator in the inside, and the denominator on the outside, 5s raised to 4 plus 9s square plus 2. So the next thing that we are going to do is we have to make 5s raised to 4 equal to s raised to 5. That is 5s raised to 4 into some value will give you s raised to 5. That value will be s raised to 5 divided by 5s raised to 4. That is s by 5. S by 5, we wrote s by 5, it will be s raised to 5. Then doing multiplication, that is 9s square into s by 5, we'll get 9 by 5 s cube plus 2 into s by 5 will give you 2 by 5s. Okay, and doing subtraction, we'll get the remainder as 6 by 5 s cube plus 8 by 5 s and in the inside of the bracket we will write the denominator value that we have taken, 5s raised to 4 plus 9s square plus 2. Now we have to repeat this process over and over again. I'm gonna do this. This value will be 6 by 5s cube is equal to 5s raised to 4. 5s raised to 4 will be 5s raised to 4 divided by 6s cube. 25s by 6. 25 by 6s. Then we'll solve this and we'll get 5s raised to 4 plus 20 by 3s square. Solving this, the remainder will be 7s square by 3 plus 2, and we continue the division by taking the value here, 6 by 5s cube plus 8 by 5s. I'm just removing all these calculations because it's so confusing. So I'll be solving this. This will be 18 by 5, and which will give you 6 by 5s cube plus 36 by 35s. And on solving this, we'll get the remainder 20 by 35s. We take the 7s square by 3 plus 2 in the inside, and on solving this we have to put 49 by 12s, and we solve this, we'll get 7s square by 3 but 0, and then after this we have 2 as a reminder. Then we'll go like, so it has to be solved by 10s by 35. It will be 20 by 35 again, and we'll get the remainder as 0. So this is how you solve it. Now that I have solved it all the way from the top to the bottom, you could see all the quotients here. This is q1, q2, q3, q4 and q5. All quotients are positive. From what we have studied until now, it directly means that the given polynomial is Hurwitz. Hence Hurwitz polynomial. That's it. So our second problem for today is over. It's very simple. It's kind of time consuming, but you have to practice this a little bit more, then only will you be able to do this so quickly within the limited available time. Next we will be going to the next question, the final question that we take for today. So this is s raised to 4 plus s cube plus 2s square plus 2s plus 12. This is our question, last question. So when you consider this, you'll know that this is not a positive total, this is not a completely odd or completely even function. So what we are going to do is we are going to split it into even and odd. But before that I have to check two other factors, that is all terms are present, and that is verified. All terms present. Next, all coefficients positive. Coefficients positive. Okay, now I am moving on to separating odd and even terms. Odd terms we'll write s cube plus 2s. Even terms we get right s raised to 4 plus 2s square plus 12. And now what we're going to do is we take the term with the highest power in the power as the numerator. So I'm going to take even term as the numerator, n by s by m by s. Then I'm going to do continued fraction in this given fraction, that is s raised to 4 plus 12 is 2s s raised to 4 plus 2s square plus 12 divided by s cube plus 2s. Yeah. In order to do that, I'm gonna write the numerator in the inside. I'm doing continued fraction right now. I'm writing x cube plus 2s, the denominator on the outside. So the first thing that we have to do is we have to make s cube equal to s raised to 4. How can you do that? S cube into some value will give you s raised to 4. What is that value? It is obviously s, right? So I'm multiplying it with s, so I could get s raised to 4. Then if I multiply 2s with s, I will get 2s square. And then nothing, 0. So we'll get 12 as the remainder. Then we are going to solve this again. Actually, there is something, some mistake that I have written in the question. Let me check that, okay. Yeah, this is 3s square, and hence this is also 3s square. This is also 3s square. Here it is also 3s square, and hence the value here will be s square plus 12. Okay, and now I'm dividing again with s cube plus 2s in the inside, and I'm dividing it, so I have to make s square into s cube, so I'm multiplying with s, so it will be s cube plus 12s. Subtracting, I will get minus 10. On subtracting, I'll get minus 10s. I'm taking s square plus 12 inside, and I'm dividing once again. I have to make minus 10s into s square, that is I have to multiply it with minus s by 10. So it will be s square plus and 0. Then I'm putting 12 on the outside, minus 10s on the inside. I have to get minus 10s. So in order to get minus 10s, I have to multiply with minus 10s by 12. So the answer will be minus 10s and the remainder will be 0. Now that I have solved the entire continued fraction, and when you consider the quotients, q1, q2, q3 and q4, here there are negative terms in the quotients. It means that the polynomial is not Hurwitz. If all the quotients are positive, we could say that the polynomial is a Hurwitz polynomial. Now that we have seen negative coefficients, negative quotients in the continued fraction division, we could not say the polynomial is Hurwitz. Hence, we will say the given polynomial is not Hurwitz. That's all for today. Thank you.